Hi, so you can see after downloading QGIS, this window will appear. I am closing the browser and layer menu. To download, you can simply type QGIS download. It will take you to this website. You can download the most stable version, or you can see for different operating systems. To download others, you can go to all releases, check for your version. If it is not here, for example 3.4.11, not here for the Windows, we will go back and then check for some other sources. Here we have other releases also for Windows 64-bit operating system. We'll click here, it will take to another website. We'll check our version 3.4.11. Depending on the operating system, 64-bit or 32-bit, you can download. Once you click it, it should be ready to download, and then simply install it. After installing, this type of window will appear to you. So this is our map canvas, the blank space. This is our menu bar where you can see so many options: raster, vector, help, and then you can see our status bar at the bottom, and then this is our browser menu, and below that we have the layer menu, and here this is our map canvas or workspace, and this is the status bar at that bottom. You can see coordinate, scale you can change 1:1000 or according to you, and magnifier to zoom out, and then you can see rotation and your project coordinate reference system. So you can click on that, so you can see, and then you can change accordingly. This is our processing toolbox. You can add it in the menu bar. Processing option is there, you can simply click and bring it, and then you can type for so many operations that you want to do: raster or vector or clip or reproject according to your requirement. So that is how a basic interface looks like. Now in browser menu, the use is you can make your folders favorite, your working folder favorite. For example, you just click here and then right click, add it as a favorite. It will be added to your browser as a favorite, and then you can simply drag and drop your files that you want to work with in the layer menu. Click, drag and drop. So you can see I've added them, and simply you can add other files like here LULC files, and then you can zoom out or zoom in to go to your desired area of interest. And then I have added a shape file as well, and then like this we can drag it up or down to make sure that which layer we want to see first. The layer on the top will be visible to us, and this is helping in visualization of different layers. And then suppose your layers are expanded, simply click on collapse all. So now it will be collapsed and it will be easy. Select, and then you can remove. Right click and remove. If you want to remove multiple, then just control and then select all and then remove. So you can see, select and control, press control, and then you can select remaining and control, and control D will help you in removing all. So now we will see how to add the data we have seen. Now we will one by one work with each type of data. Like raster data, we have DEM and LULC. So first we will see how to download the digital elevation model DEM for any area. In Google type, okay, first we will see about the LULC. So in Google type history LULC. First link will be there for the living atlas. Click on that, and then you can see this the details about this data, 10-meter data. And you can see that in the description as shown in the video, you will be taken to a page where the details about this LULC data are given, like from what date it is acquired, from 2017 onwards, what are the various classes, what is the projection system, and what is the cell size, that is 10 meters here, and what is the satellite that has taken this data. So this is important for us, the class definitions, because based on this we will know that okay, these are the classes and these are the classes I want to merge or whatsoever I want to do with this data. Now let us just move forward to see where we can download this LULC data. This was about the description of the data. So just go back and then you will have an option, enable the entire GIS community. Click on application. On this page, click on application. It will take us to a page where the entire globe is divided into several number of tiles. Now depending on your area of interest, you can download any one of the tile. So suppose just zoom it out to your area of interest roughly, and then you just click on one tile. This is called one tile, and then once you click, it will ask you that which year you want to download it for. Once you double click that or single click, it will take you to downloads, and then see here in the video it is downloading. Likewise, you can download other data also. We have seen for LULC, and here the thing is you can download only from 17 onwards, and 17 data is somewhat inaccurate as per the website. So now we'll see for DEM. Type USGS DEM, first website, click there. To download DEM, you need an account, an Earth account, USGS Earth Explorer account. But as of now, we will just visualize. Left side, you can see we have the option of uploading the shapefile of our area. So suppose you want to download the DEM for a particular area, upload the shapefile, it should be okay. And then if you don't have, just click here, use map. So now this selected area, it becomes your area of interest. So you can adjust the vertices. So I'm bringing it down to India. So some part of, small part of India, I want to take the digital elevation data. So now you can just adjust the cloud cover. Suppose you can reduce or increase, and then go to data sets. Yeah, here in the polygon I have chosen a polygon. Yeah, you can choose any other predefined area also. And then you could go to data sets, and then here go to digital elevation, and then you have an option called SRTM, that is the SRTM source DEM we are downloading. And then you can click on 1 arc second, that is 30-meter resolution DEM, and then you go to results. It will show you a couple of tiles that can be that are covering this area of interest. You can see this area of interest is large, multiple tiles are required to cover the same area. So these tiles, if you want to cover this entire area of interest, you need to download all these tiles and you need to merge it, which we will see in our video, in the coming video. So like that you can cover all the study area. You can just preview it. So you can preview one gray band scale DEM, you can see. So the darker and lighter tones define the different shades of elevation. Now once you download and once you download, to download you need login, your DEM data should be ready. So we have seen how to download DEM and LULC. So now like that we can download our soil area also. So we can just go to QGIS, and then I have already downloaded the DEM data and LULC data. So I'm going to simply load my subbasin shapefile, which also I have taken. So we can take this shapefile from HydroSheds. As of now I have delineated it using SWAT. So you can load your shapefile. You can just open the attribute table to know more information of what is there in each boundary. So you can see this entire basin is divided into 5. So you have subbasin column, you have 5 subbasins, and then you have a lot of information about length, area, slope. So many information is there. So you can just sort it. If you sort it, you can see, you can select it. So suppose I have clicked on the first row or fourth row, it is helping me to select. You can see in the yellow color it is highlighted. Suppose you want to select multiple, press Ctrl and do the same process. It should be done. Now like this you can select or deselect also. Deselect option is also there, so now it is deselected. So likewise you can play with it, and then you can also check out some more properties. So just right click on that layer, and then you can go to properties, and then you can see some more information in the source, and information that what is the type of this particular file, what is the projection system. So projection system here it is 43N. So anytime when we have to reproject, so how do we reproject a particular vector layer? So in the processing toolbox I will type reproject. As of now it is 43N, but suppose if I want to project it to some other coordinate reference system, I will just load my import input shapefile and the target CRS, that is your target coordinate reference system. Select that, and then in the filter option you can type whichever coordinate system you want to project it to. Let us just reproject it into 43N, or let's say 44N. So you can see in this that 43N UTM 43N is our projection system, and WGS 84 is our datum. So once you select 43N, you can see a particular part of the country is covered. If you select 44N, like I have shown, in 44N you can see the remaining part is covered. So like that entire country is covered by 4 to 5 zones, 42, 43, 44, 45, like that, from west to east. So like that we can assign, click on run, it will be reprojected to your 43N. And then you can also okay, so I'm not saving it as a permanent layer, I'm saving it as a temporary layer. If you want to save it as a permanent layer, just give a path, it should be able to save it. Now just click on save if you want to save it, or else you can give it a name reproject layer and you can save it, or else you can leave it as a temporary layer. It is up to you and depending on your requirement. So we have seen, this is pretty much about the reprojection of a vector data. Remember that vector data should be in projection coordinate system, because you want to compute area or you want to compute length, you want a 2D representation. Then you can also see here, once you have reprojected, you can cross check in the same way. And then we are also looking at here, we can look at some other properties. So the project a coordinate reference system, so to do that, go to project, go to properties, and then you can go to CRS. So what we have seen just was the layer reprojection, but now this is a project coordinate reference system. So likewise you can set the process same, just the thing is you are doing it for project, so it will be reflected in the right corner also. And a layer you can do individually for each layer. Now what we are going to do is we load some of the raster data. So we have dem, so just load the dem, and then you can zoom it or zoom out, zoom in or zoom out. This is our dem. So we can check the projection system for this also. And then suppose I want to see that this is a dem tile, I want to see where my study area lies, so it is only a part of it. So suppose I want to clip this part of dem, then how do I do it? So that is the thing that we can look at. But before that we need to check our projection system. It is important that our layers are in the defined project system, and sometimes we may get error due to projections. So we will check the properties, we will see in the information, it is in, as you can see, it is in WGS 84 geographic. So what we can do is we can reproject this dem. So in the processing toolbox I will type reproject. Now it is very important that when you are reprojecting a raster, you do take the option under raster. So there is an option called warp. Just load your input layer, and give the target coordinate reference system that you want to give, and then select it. Suppose right now I want to give 43n. Okay, so you want to give 43n, you can type 43n. If you are not able to find, just type the EPSG because it is unique, so it will be able to filter it better. So EPSG and 4326, that will give you 43n. Sorry, that will give you WGS 84. But if you type here, if you want to give it some other projection system, then you can give accordingly. Okay, so here you can see that the DEM is reprojected. You can check under the properties that whether it is reprojected or not. So this way you can see the projection system for raster and vector. Okay, now suppose you want to perform some other operations, then you need to reproject it accordingly. So let's just look at our subbasin shapefile and let us play around with some more properties. You can see in the attribute table we have subbasin numbers, we have area. Suppose we want to give symbology based on these attributes. So right click, properties, symbology, and then as of now it is a single symbol, you can give categorized, and then it will ask you by which attribute you want to symbolize it. So you can select that particular attribute, classify, and then you can see that now it has given based on the subbasin number. So we have 5 different subbasins, that's why you can see that this has changed. And then you can use this color wheel to give different sets of colors, and then you can just play around, and you can see the all of these color ramps, and then you can choose any of the things that you like. The it completely depends on your like what type of map you are going to create. You want to create a subbasin map or you want to create some other attribute. We will see in the coming video how we can add more attributes also. So likewise, just apply. Okay, now you can see this is your map representing subbasins. We can also add labels. Let's just go to this one. Yeah, I'm just showing you some more symbology here, but let's just go back to our previous one. I think that is better, so let's just apply it. Okay, and then you can see that this is now done. Now you can assign labels so that you know what particular thing it is. So just go to single labels and then assign based on the attribute. Select the attribute, and then you can select the font, you can select the size of the particular label, color, and apply it. Okay, you can see 1 2 3 4 5. This represents nothing but one is the first subbasin, second is the second, and so on and so forth. So like this we have seen that how to play with the symbology and how to assign labels to a particular shapefile. We have also seen how to reproject raster and vector, and then we can see that how we can save it as a shapefile. Like what all we have done, we can just export it a particular layer. So just export it, give it a name, and then you can just save it as ISRI shapefile because it is a shapefile format. So remember to check the extension, click on save, and then in this dialog box you can just click on OK, leave other things as it is. So click on OK. Now this is saved with this file is saved. So like this you can export any particular layer, be it raster or vector. Just remember the extension here. So this way, suppose if we want to clip first subbasin, so that way you can do, like you can simply, yeah, I'm just collapsing all, and then suppose I want to delete the remaining. So like I told you, select and press Ctrl D, it will be able to remove it. Now suppose I want to select some part of the basin, so I will go to the select option, and then let me click some part of the basin, let's say 5. So this is highlighted. Now simply I can just export it as a save selected feature as shapefile. So like that I can clip any particular vector. So the remaining process is same as shown. You can simply follow it. Select a part of the basin that you want to clip and then just save it as a shapefile depending on what particular data you are working with. So see, we have clipped out basin number 5, subbasin 5, and then you can see the attributes also, and you can see that from the entire basin it has been clipped out. So this was about vector clipping. Next we will see about raster clipping also, but I think in this video up to here only, and we can, like you can see, I am showing that how we can clip multiple files. So I'm just going to select both, and I will just go to export, and I will save select feature as shp. So like this you can see that it has been clipped out. So this was about the vector clipping. So I hope in this video we have seen how to add raster, vector data, raster data, how to reproject both type of the data, how to download them, and then some basic operations with the vector clipping. And then we have also seen that how can we assign symbology, how can we assign labels, and then how can we export it and save it in our system. That's